Hello there, my gorgeous friends of the internet. I'm happy to announce to you that I'm getting very close to the completion. No, that sounds weird. To the completion of the course, of the JavaScript course. So what I thought I'm gonna do is share a small part of it here on YouTube for you to enjoy and see if you like it. We're gonna talk about asynchronous JavaScript. It's a harder topic to kind of understand, but I try to simplify it as much as possible. So again, this is a small chapter to kind of get you up and running with it, and then in the course we're going to start building out projects and all of those good stuff. Again, I have like 20 hours filmed. It's going to be amazing. Next week I'm going to start sharing like everything that I have in the course, see if you like it and everything. And yeah, that's going to be it. So enjoy this part and I'll see you in the next one. Okay, in this chapter, we are going to talk about asynchronous JavaScript and how that is useful for us. So a big thing that you're going to see on the internet is something called AJAX. So what is AJAX? AJAX means asynchronous JavaScript and XML. What is XML? We don't care because nobody uses XML anymore. But XML is basically a format, a lightweight, easy way format that people use to kind of send data from server to the browser or from server to another server and things of that sort, okay? But again, we're not going to be using XML, we're going to be using something called JSON, all right? Which is, again, just another format of sending data, a common way, because you're going to see that we have to send data from
Hello everyone. Today's video is going to be a quick video where I show you how to use the Fetch API built into the browser in order to make asynchronous requests to different network resources by using get, post, put, whatever it is that you want to use. So let's get started now. Welcome back to Web Dev Simplified. My name's Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. So if that sounds interesting to you, make sure you subscribe to the channel for more videos just like this one. And to get started, I have just a simple JavaScript page open on the right-hand side, which is open the console on the right-hand side. So everything that we put inside of this left side, as you can see, is going to be acted upon in the right-hand side. So whatever we do over here, we can see the result of over on the right. And to get started, as I mentioned, we're going to be using the Fetch API, and we're just going to be hitting this fake API, which is going to give us back some fake data. So this is going to, for example, give us all the users side of this API, or we can just get a single user, for example. And the way the fetch API works is you pass it a URL as the first property, and then it has a second property, which is optional. And this is all of the different options that you want to pass to it, such as if you want to do a post request instead of a GET request, you're going to need to use these options. But to get started, we're not going to use any options with fetch, and we're just going to log this out to see exactly what we're getting returned. So we'll say console.log of fetch, and if we save that, you see that we're getting a promise on the side here. So we know that fetch is promise based, which means that we can use async await, or we can use .then and .catch with it. And if you're not familiar with promises or async await, I have links in the description and in the cards that you can check out those videos that I've made on both of those topics. So to get started, what we need to do is we need to say .then, and fetch is going to return to us a response. So we have a response object, and we're just going to log out that response object to see exactly what this looks like. And if we save that, you see we get a response that says that the status was 200, says status text is empty, OK is true. So we know that this was successful, and it has a body, which is going to be all of our data. But this body of data is actually not accessible directly from the response object. We need to call a method on it to convert this response to JSON, since we're actually using JSON data. So what we need to do is say res.json, and this is going to return another promise. So then we need to use .then again, and this is going to be our actual data. And we can say console.log of that data. So as you can see, we have all of the different data on the right-hand side here. It has page numbers as well as all of the different users that we're getting from the API, and that's working great. Everything's looking good. But what happens if we want to get a single user? And for example, we're going to get user 23, which does not exist. So we're going to get a 404 status back. And when we save this, you're going to see that our GET request actually happened, but we still ran our successful .then code, even though we had a 404 being returned. You would think that since a 404 is an error, that it would end up in a catch statement like this, where we have an error, and then we would just want to log some text that says error, for example. You can see we're not getting any error text. And that's because the way fetch works, even though we're getting a 404 response, which is a failure of a response, fetch always succeeds no matter what, unless there's some form of network error where the actual browser has a hard time connecting to the internet. The only time you're going to get a failure is if you have a failure with fetch itself and not with the API you're calling. So what you need to do is inside of your response, you want to check to make sure the response is okay. So inside of here, what we can do is we can say if res.ok, then we know we had a successful response. We're just gonna, for example, console.log success. Else, if it's not successful, we're just gonna say something else.
Welcome back, everyone. Today what we're going to do, we're going to start writing our first asynchronous JavaScript code. And it's not going to be anything special, but before this, all of this section that we have covered, they were done in slightly different way. They were all synchronized, means all of the JavaScript code was executed line by line, and that was synchronously done. Now, drag this on your desktop or wherever you're working. So find this folder. Inside you will have the final and the starter, and open with the text editor the starter. So I do have open the starter, and inside I do have lecture 1, which we will remove. This is the JS file, and from this lecture on you're going to create a new file and put it here, lecture 2 for example, and link it here, right? Don't forget that, because sometimes to work with Google, I use ES6. I'm not going to do ES5 anymore. Using ES6, I'm not going to do ES5 anymore. If that is okay. So I'm going to say constant here first. So I'm going to create here function, right? And I'm using the arrow functions here, and I'm going to say console log. And I'm going to say the first function is here. Okay, now I'm just going to repeat the same step. I'm going to maybe 1, 2, 3 more times. This will be the second. Make sure that you put here second. This will be the third, and fourth. Now this, we're going to say final here. Okay. Now, this is nothing new. We have done this, and we need now, if I go back to the console, I don't see anything because we need to call the first function. Then if I go back, now I have the first function is here, and I manually need to call all of these functions. Now, this is nothing new. We have done this, and we need now, if I go back to the console, I don't see anything because we need to call the first function. Then if I go back, now I have the first function is here, and I manually need to call all of these functions. So I'm going to say second, third, and the final, right? Good. Now if I go back, I do have the output of the console log. Nice. So this is nothing new, nothing special, but what I was trying to tell you that this is synchronized way, and all of the lines are executed. We're calling this, and it's executed this. We're calling this, then it go to this function, and this line is printed out. So this is called synchronous way of working, and this is how we have done a lot of things so far. Okay, now one more thing. Instead of calling all of these functions, I'm going to cut it from here. I'm going to put it there. Let's just shift it a little bit on the right, save it. Now I'm going to have the same result, right? Even if I refresh. Why? Because I'm calling them from the first function. So this is nothing new, nothing special. But how this can be changed, and why we going to learn the new asynchronous way of JavaScript. So the best way to show you is to use the set timeout function. So I'm going to set time function on this here. So I'm just going to comment the console log. In here, I'm going to set timeout. So this is a function. Okay, inside this function, it takes 2 arguments. The first will be the function, in the second argument will be the time. So the function, we will write the arrow function here. It can be or it can be without arguments. Okay, so enough talking. Let's create this function. Okay, arrow function without any arguments, and this will be the body of that function. Okay, the second parameter, as I told you, will be the time. This time will be in milliseconds. So if I put here 3,000, that will be 3,000 milliseconds, right? And that will actually mean 3 seconds. So first we have a callback function, which will be arrow function, and the second, so no arguments here, this is the function, and the second will be the timeout, and that is in 3,000 milliseconds. So what this timeout means, okay, after 3 seconds that are passed, this function here, whatever we're gonna put here, it will be executed. And what I want is just simply to put this guy here. Okay, so what do you expect to be the output? Do you expect to be first, second, right? I don't write the whole line, I'm just saying third, in the so this is not normal behavior for us because we haven't done anything like this. So you didn't expect this at all, but this is how the new asynchronous way is working. And we will cover much more about this in the following lecture. This is just to warm you up to get used to what we will do, right? And this is the normal, and this is nothing wrong. I mean, I'm gonna say again, because we don't stop the flow of the execution. We just wait for 3 seconds, and after that, this function was executed, right? And this asynchronous ways allows us to the function to work in the background. So more about this in the following lecture, but this was the old way, how we write it without this function, and you saw that it was first, second, third, and fourth, but when we do the timeout function, this was not there until 3 seconds passed, and yeah, it is coming as a final one here. So this is not the final. We should put here fourth final function is here, right? Good. Now look at this. It will be first, second, instead of third, it is fourth final function, and then comes the third one. Okay, we're gonna talk about this. Don't worry if you don't understand too much right now, but it will be easy from now on. So take care, and I will see you in the next one. In today's lecture, we're going to talk about the difference between synchronous and asynchronous, and also we're going to talk about the event loop. A lot of the programmers, developers, especially JavaScript developers that are working at the moment, they don't know about the event loop. They don't know what is happening behind scenes because they just code it. And some of them, they don't even start from ES5, they start from ES6, so they don't have that knowledge of how we create the functions, how we deal with the prototypes and stuff like that. But you do have that knowledge, and now I want you to learn this because this is very important. Okay, enough talking. So synchronous. All of the things that we have done so far, they were synchronous statements. The statements were processed or execute one after the other. Also, that was for the instructions or the methods. So the asynchronous function will run in the background. We already saw that with timeout function. So the JavaScript will not block its execution. That will avoid these code blocks. And this is possible because of the event loop. Now, on the next slide, I do have this here. It might sound a little bit of intimidating, but it's not. Actually, on the left we have execution stack, message queue on the right, console, in our
now.
Hey everyone, welcome to this video on the call stack. My name is Colt, and first I just want to apologize for this recording setup. I'm still working on it. This microphone is way too big, so I'm working on something better. But for now, we're just going to work with it. So the call stack is something that, in my experience, a lot of students aren't really comfortable with. They know that it exists as this like amorphous blob that they just don't want to dive into. They know it's a thing, but they don't really understand how it works and why they should care. So let's start there. Why does it matter? First, it's fundamental to how JS works. It's always good to understand the language you're working with, right? It's a good thing to know what's happening behind the scenes. But second, and I think this is most important, it's really helpful when you're debugging your code. So JavaScript, Chrome and Firefox and pretty much every browser today has built-in call stack debugging tools. So you can see what's happening at any point with the call stack. And I'm going to show those in this video. And then finally, it does come up in interviews, so absolutely worth knowing for that. Let's start with a really important question, which is, what is the call stack? I like to think of it as sort of like a to-do list of function invocations. So if you have an application, you call a function in the last line of that app. That function call might result in 5 other function calls, and each of those might have cascading function calls, and they might be waiting on results of future calls to come back until our final original function call finishes. So JavaScript can basically only do one thing at a time. It's mainly single-threaded. Technically, there's something called thread pooling that happens, but we're going to just ignore that. Just assume that one thing is happening at any given time. So JavaScript needs to keep track of the history of things, sort of a list of what is waiting to be returned, which functions have been invoked but aren't done yet. So that's what the call stack is. It's a structure that stores it. So it's like a to-do list. And the reason it's called a stack, by the way, that's a common data structure. And the way that a stack works is that it's a last in, first out structure. So I like to think of it as like a pile of books. I have a pile of books over here. You might be wondering what I was doing with that. If I want to add a book to a stack, I add it to the top, right? I'm not going to try and add it to the bottom and like shift everything over. I'm going to add it to the top, just like this. And then if I want to remove something from a stack, I take it off the top. So the last thing that was in this red book is the first thing out. I don't remove from the bottom. That would cause a book avalanche. All right, that's enough of the books. Push those out of the way. So in a similar way, here's a little visualization of some function invocations. Don't worry about what the text says, but we have a function called main, and our call stack takes note of that. But it actually calls multiply, and our function multiply for some reason calls another function called something. So these are all added to the stack. So this was the last thing, it was added to the top. So it's the first thing to come off. Here we go, it's popped off, then multiply, and then finally main is finished. Last in, first out. So to summarize that, when you invoke a function, the details of the function call, the invocation, are saved to the top of the stack. They are pushed to the top of the stack. And then when that function returns, or whenever any function returns, the information about the invocation is taken off the top of the stack. It's popped off, taking the book off. So here's a simple example. We have a function called multiply, and then it's being called down here on line 5. So the way that the stack works, what's the very first function that's invoked in this application, or I shouldn't call it an app, in this code? There's something called the main function. Think of it as like the most basic top level function call in every single JavaScript file. So main is added to our stack, and it says line 5 is where we invoke the first function. This is not a function invocation, it's a declaration, so nothing added to the stack. But then in the main function, we're calling multiply 3, 5. So that means we need to add a frame, is what it's called, a stack frame, we'll come back to that, to the top of our stack. And so now we have multiply and also the line number 2. That's it though, because in multiply, the only line is a return. So remember, when we return something, we pop it off the stack. Here we go, there we go, just popped it off. And now our main function is done. There's no code after it, so it's done and our stack is empty. So we'll do a more complex example in a moment. Let's come back to stack frames. So this is a visualization of what a stack frame is. It contains some information about that function invocation. It contains the function that was invoked, the name of it, like multiply. the parameters that were passed in, and the current line number. And I'll actually show you this in Chrome in the debugger, where we can look at a call stack in just a moment. All right, so I'm in the Chrome debugging tools, and I have a little snippet I've created with some code. And over here in the debugger, there's a little section. I'm going to close everything except for call stack, which currently shows nothing. I need to pause my code, need to add a breakpoint, and we'll start to be able to explore the call stack. So this code is really simple. I have a function called first thing and another one called second thing. And I'm calling second thing first, and that returns first thing plus the string second thing. So if I call it, if I just run it on its own, I'm going to use, it's a snippet, so I can do command to return, and I get first thing, second thing. But now let's see how that actually happens. So I'm going to add a breakpoint right here, and now I'm going to run the code. Command enter, or I could click that button. Okay, so we have our main function, in this case, the way that